Strategy. I'm Zoe Burr.
I'm Rebecca Lundquist. I'm Grace Hansen.
I'm Corinne Severide.
I'm Claire Myers. I'm Shelley Franklin.
And I'm Erica Broker.
So our design strategy to support our mission is to improve the robust design by incorporating Creo into our design, build, and test process. So we've incorporated many different aspects this year to help improve our robot, and the biggest change is the use of Creo Parametric. So we designed our whole entire robot using it, including many custom parts, like those three. And because of our use of Creo, we won a $500 grant from PTC and a 3D printer from Coca-Cola, EcoCycle, and First. We have also 3D printed some of our parts that we've designed, including the ball channel, this ball holder, the battery holder, and a cam, which is, down there. Okay.
What is that part do?
So the cam is when it spins, see, it gets bigger, so it causes this trap door to come up and it launches balls in the air.
So it snaps. When it goes all the way around, it snaps back and hits the ball.
And all of these enhancements have allowed us to complete our design strategy and support our mission.
Okay, so our drive strategy to support our mission was to improve our base design by using an engineering lifecycle, incorporating Creo drawing, and have 3D printed parts in our robot, and also to have a unique robot that performs well. To support our mission, we used an engineering lifecycle. First, we would brainstorm. Once we had an idea, we would prototype it and revise until we could get it perfect. Then, once we got the prototype we liked, we would design it and then make a final design. After our final design, we would build it and test it until we got the base we wanted. To support our mission, we needed to create multiple bases and designs. When somebody would think of an idea, they would sketch it out and then prototype their idea. Our first base was a simple base with front-to-back wheels. Our second prototype was almost the same, except there was holonomic wheels on the outer corners. The wheels took up too much space, so we had to create our third design. Our third design was much larger, and the holonomic wheels were geared to conserve space. Unfortunately, this base was unstable, so we created our fourth base, which was a 17.75 cubic inch base. Our current base is a U-shaped base with protected wheels. Then, to maximize space, we took off the outside bar and moved the wheels out. This gave the manipulator team more space for their attachment. You can see a picture of our base on page 39 in the engineering notebook. All the wiring is attached to a panel on the side of the robot. All the motor controllers are attached upside down for easier wiring. We use ferrules to wire to help the wires stay in the controllers, and our battery is attached to a 3D printed holder. All our motors and wires are labeled, and we use a power distribution for our wires.
The manipulator team's strategy to support our mission is to improve our robot scoring capabilities by building attachments that we research, design, and prototype before we actually build them. After our first regionals, we realized that our main attachment that brought the balls up to the top goal was not fast enough to earn the amount of points that we wanted. So we researched ideas that would be quicker between collecting balls and putting them in the top goal. Eventually, we decided on launching balls. At first, we were going to launch the balls with two wheels spinning inwards like a tennis ball launcher. When we prototyped this idea, though, we found that it could not get to the high enough speed that we wanted to launch the balls at the right height. We found that, and then we prototyped our next idea, which we created a plywood board with springs attached to it. When the board is pulled down and released, it smacks up and hits the ball, which launches it into the air. This worked very well and is now our current attachment. The way we collect balls has also changed from our first regional. Instead of using zip ties, we use plastic tubing squeezed between two metal bars. The bars are attached to a motor and a support on the other side. While the balls are being collected, they are pushed up against a ramp and then moved on to the ball channel.
The engineering notebook strategy to support our mission is to improve the engineering notebook by documenting everything throughout the season, clearly showing our thought process and highlighting all of our community outreach events. We wanted to show our joining a mission this year. We accomplished this goal for our engineering notebook. The engineering notebook is divided into many sections, including a team section, a business plan, our mission and strategy section, an engineering section, our qualifications for awards, community outreach, preseason meetings, and our season meetings. In the back, we also have a requirements document. Our business plan is on pages 9 through 14, and that outlines our plan for sustainability in the future. This also shows our budget that we followed for this year. There you can see some of our various sponsors. In the mission and strategy section on pages 15 and 16, you can see our goals and team strategy. Then you can see what we achieved this season in relation. On pages 17 through 44, we go into extensive detail about our robot and the engineering section. It has our various strategies for the 3 teams: base, manipulator, and programming. Our team also designed our robot off of 2 life cycles, programming and robot build. You can go to pages 45 through 49 to see what we did in direct correlation to the guidelines. We devoted much of our notebook to record our different outreach events. You can see the summary and the details of these events on pages 50 through 88. When we got to the season, we developed a specific way of recording each meeting. We start out by giving the date, what kind of meeting it is, where we had it, who attended, a start time, and a signature from the person who recorded it. Then we list our tasks we are focusing on for that meeting that support our overall strategies and the team mission. At the end of the meeting, we give a status on how far we got in finishing that task. Recently, we also started to talk about what we learned in relation to our tasks. Then we capture important designs and engineering concepts there. We have successfully conveyed all our team has done in a clean, fun, and organized way in our engineering notebook.
Our community outreach strategy to support our mission is improve outreach by making more connections at events and by documenting community outreach in a notebook right after the event. If you want to follow along and see all of our events, please see pages 50 through 88. Since last March, we have done a grand total of 48 community outreach events for a total of 1,018.1 team hours. Our first highlight is our robotics rush event in late May, and as a result, we increased the number of girls in Eagan FTC from 6 to 27. We have helped fund and mentor them throughout the season. A second highlight is when we went to the Pacer Center for Girls with Disabilities twice and taught them how to program FLL robots. We also have organized 2 University of Minnesota tours. One last highlight is that we organized a 5K race for robotics with the Lazy Bots to raise money for both of our teams. We also have connected with a lot of different companies, and our team has received sponsorships from the majority of the companies we have connected with and have raised over $5,000 to support our team and the 3 other all-girls teams we started. Our plan for sustainability comes from fundraising, national corporations, and organizational grants. We have had a very successful season in community outreach with the connections we have made, as well as the numerous events we have done. And community outreach is explained a little more on this board.
Our programming strategy to support our mission is to enhance programming by using more sensors during autonomous intellia and keep code well organized and commented and use a utility file to store reusable code. Our goals for programming include using advanced methods for programming and reusing code so it's more efficient when we program. This is our programming lifecycle. Please follow along on page 18. These are the steps that we took to complete our programming. First, as a team, we determine what missions we want to accomplish and what order we want to get them done in. Step 2, we then mapped out our autonomous routes that we want to perform. Step 3, after that, we designed our pseudocode. Step 4, we then programmed our skeleton code while the robot was being built. Step 5, we added the exact measurements to the skeleton code and fine-tuned the programs. Step 6, once we finished that, we tested our code on the field and in different scenarios. Step 7, we then revise, debug, and solve any problems we ran into during testing. Step 8, we then finally repeat Step 6 and 7 until all the problems are solved and the program is the way that we want it. We included many strategies into our programming, and they include reusing code. We created a program for all of our reusable code called utility 2015.c. We created it so we could only have one moment to change one part of the code and common code in one place. We reused code for both teleop and autonomous, and we passed in parameters into functions to make functions more specific. We also used a lot of comments so others can better read and understand our code. We created multiple autonomous programs, and for this tournament, our mentors and coaches have been more hands-off and let us do more on our own. We have learned a lot from this, and it has allowed us to build a strong foundation in programming. Our knowledge about programming has skyrocketed since our first tournament. These are the programming techniques that we use to help us fulfill our strategies and complete our goals.
Our ambassador strategy to support our mission is to improve our match performances by talking to our alliances and making intelligent choices based on their robot and ours. We also have and will continue to develop strong relationships with other FTC teams. We have greatly improved our scouting this year. One thing we did is we decided to have 2 different types of scouting. We will scout before the match and also during the runs to see how consistent teams' robots are doing and how well their day is going. To make the scouting faster, we have a list of team names and numbers provided by High-Tech Kids. Using this list, we will then split up teams in half and work with the Team Tempest to reduce the amount of time spent scouting and make it more efficient for both our teams. We hope these plans will help improve our robot runs and help us reach our team goals.
Any questions?
Absolutely. A ton of questions. First of all, that was a wonderful presentation. Thank you very much. You covered all of the bases. That makes my job a lot easier. Oh, I don't know where to start. I think I'll start from the end and go to the beginning. So I see that your community outreach numbers are changed.
Yes,
Did you make the board and then do another event and
We
have
made
to?
the board for our first tournament, and we've done more outreach since then.
When was your first tournament?
I don't know,
It
November.
was the first one. November
You
20.
did the very first tournament and then the very last.
Yes.
So a lot has changed on your robots.
We actually
We
took apart our whole
tore apart
robot and
things.
it was in pieces and we started new.
Oh, wow. Is that in your notebook?
Yeah,
Can
you
you
can
talk about
see,
that?
we go into our post-regional, if you see the engineering section, we go into our post-regional, what we did wrong, like we talk about how our wheels had to change and stuff like that, so that's an engineering section.
Okay, oh my gosh, we're almost out of time. Did you say you had, like annotated your code?
We have it printed out, don't we?
It's in the back of
It's
the,
in the back of the engineer's notebook.
And did you like have comments on it, like what it does and
Yeah,
such?
definitely.
Check that out. Do you have fundraising stuff in your notebook at all?
in the
You talk
business
about-
plan.
Okay,
Talk about
great, so
that
there's
too.
a business plan. Also, I loved the having us like follow along in the book. That was stellar. You talked about this engineering life cycle. Where did you get this idea?
Well, the programmers had used it, and then we thought it'd be a good idea to use it for our base to keep it more
Yeah.
organized.
But where did that idea of the life cycle come from? Is that
We thought we should have something more planned out, because
Yeah.
when we were brainstorming ideas, we'd always like make the idea, figure out that it didn't work,
Yeah.
and then just go back to the drawing board
so?
again.
Did you like write this yourself? Like,
Yeah.
came up
We
with-
just kind of
Yeah.
wrote it down on paper and then we worked on it into the engineering notebook and drew it up
And
there.
also last year, we didn't use Kura, so we had to figure out a way to kind of incorporate it and make it functional.
Yeah, well, that is really polished. That is
Lots of
very.
fun.
You also mentioned company connections. So who were you reaching out to and what were you learning?
So these are our sponsors.
Okay.
Kind of messy here.
because we usually reach out to sponsors at different events like Robotics Alley and then just other different robotics community outreach events we've had. So we've reached out to all those companies like Maverick Software and PC Robotics, PTC, at Robotics Alley, and Inver Hills Community College Expanding Your Horizons STEM event, where we just presented. It was a camp for girls looking into STEM careers, and they could there were a bunch of different stations set up, and then we were one and we just showed them about girls in FTC robotics.
We also exchange quite a few emails with sponsors, potential
Often-
sponsorships.
Oftentimes at those events, like companies come up to us and talk to us. So,
Like they're interested in robotics, and then we just want to outreach to them.
Did you communicate with any companies in non-sponsor ways, like just to learn about what they did or to ask any questions?
At Robotics Alley, well, it's pretty much where there's a ton of different companies, a ton of different robots and inventions and stuff like that, and we just kind of went around and visited all of them, so we just got to kind of talk about them, and we discussed our robots and what they have, and we just learned a lot, like with the community outreach is split between outreach that we did and stuff where we also learned ourselves.
Yeah, we have a separate section in our community outreach section, one that focuses more on when we actually talk to companies, and one that when we learn from companies.
Yeah, because one like big STEM engineering outreach event where we learned was when we organized one of the University of Minnesota tours. We got some people from the university to present to us and some other teams that we invited. And then we learned a lot from that. We learned about business startup. One of the professors there talked to us about robotics. It was really cool.
That sounds fun. When did you do that?
It was last summer.
Yeah, it was.
There was one in July and one in August. I'm not
Wow.
sure.
So like summer stuff.
Yeah.
Not everything.
Most of these outreach events we did during the summers.
That's
Pretty
great.
much met regularly for outreach.
Yeah. Oh, I have so many questions, but we're almost out of time. I guess my last question, because you've done so much outreach, what's been your favorite outreach event?
I really liked Pacer Center with
Yeah.
Girls with Disabilities because it was really fun to just work with them. And one funny story from that was one of the girls, we were teaching them how to program. She just wanted to program her robot to just go in circles. Like she programmed it to go like in circles like 1,000 times. And it was just like spinning and spinning and spinning and spinning and spinning and spinning. And so eventually we just had to stop it so that she didn't run out of battery. But it was really fun to work with those girls.
It was cool to just teach them and see them learn.
And they really enjoyed it, so that was so fun to see that other people like it too.
It was the first year you've gone there.
Yes.
Would you go back?
Oh yes.
We did, we have done two
Okay.
outreach activities there.
Yeah,
And we're
great.
planning more for the summer.
Of course you are. Well, awesome. That's great. I don't know if you had anything to say. I kind of.
No, you got them all.
That's
You got 'em all.
fantastic. Well, I'll let you guys let you out of here then.
Well, thank you
Good
very
luck
much.
today. Thank you so much.
much.